Okay, so think about this for a second. Have you ever wished an AI could actually learn and remember things? Just like we do. I'm not talking about for just one conversation, but forever. Well, today we're going to explore a brand new idea that might just make that a reality. It's called nested learning. I mean, let's face it, large language models, LLMs, they feel like they can do just about anything these days, right? They're writing code, they're whipping up poetry, they're having conversations that are just shockingly human. There's no denying it, their power is absolutely incredible. But here's the catch, and it's a big one. What if all of that incredible intelligence has a fundamental, kind of hidden flaw? What if after all that massive training is done, they're just frozen in time? Like completely unable to form a single new long-term memory. This is exactly why your AI assistant has no clue who you are from one day to the next and why it can't really truly grow and learn with you. So, this leads us right into a problem that researchers have been wrestling with for years now. The best way to think about it, it's like a kind of amnesia, but for AI. And it's this fundamental flaw that's really holding these amazing tools back from what they could truly become. Now, the technical term for this is catastrophic forgetting. And honestly, it sounds dramatic because, well, it is. When you try to teach a standard AI something new, it doesn't just neatly add that new knowledge. Oh no, it often just overwrites and completely destroys what it learned before. Just imagine this. You spend months learning French, and then you realize you've completely forgotten how to speak English. That's catastrophic forgetting in a nutshell. The researchers behind this new work, they use a really powerful analogy to drive this point home. They compare today's LLMs to a person with anterograde amnesia. And this is a very real condition where someone literally cannot form new long-term memories. You're basically stuck with everything you knew up until a certain point, and every new experience, it just fades away. And that is exactly what's happening with these models. Their knowledge is trapped in their pre-training, plus whatever they can hold in the very short, fleeting context of a single chat. Okay, so if today's AI has a form of amnesia, what's the cure? Well, it turns out the gold standard for learning, for adapting, for remembering, it's right inside our own heads. Yep, the human brain is the ultimate model for what scientists call continual learning. And when you put them side by side, the contrast is, well, it's pretty stark. You've got current AI, which is static. Its knowledge is basically frozen. Then you have the brain, which is constantly changing thanks to something called neural plasticity. AI forgets catastrophically, but our brains are masters at consolidating memories at different speeds, right? Some things stick for a minute, others for a lifetime. AI is stuck in this tiny little context window, while our brains just seamlessly weave together short and long-term memories. That is the gap we're trying to close here. And you know what? Closing a gap that big isn't going to happen with a small tweak. It requires a totally radical new approach, a whole new way of thinking about how we build and train these things. And that new paradigm, that's what's called nested learning. All right, so here's the crucial point. For the longest time, researchers have treated an AI's structure, its architecture, and the rules it uses to learn, its learning algorithm, as two completely separate things. It's kind of like designing a car's engine without ever talking to the person writing the driver's manual. They were just in two different worlds. Nested learning comes in and just completely flips that on its head. It says, hey, what if the architecture and the learning rules are actually the same thing? It looks at an AI model as one single unified system, a system of a bunch of smaller, interconnected learning problems, all nested inside each other. And here's the kicker. Each one learns and updates at its own unique speed. So what this creates is this incredible system where different levels of updates are all happening at the same time. You've got these fast updates, which are like your short-term memory, just reacting to what's happening right now. Then you have medium updates, which are for learning a new skill over a little more time. And finally, you have the slow updates. These are like our long-term memory, where the really important core knowledge gets locked in. And it's all happening together in one single integrated system. Okay, so that's the theory. And it sounds amazing, right? But the real question is, how does this actually work in practice? I mean, how do you take these ideas and build a real AI with them? Well, this nested learning paradigm really gives birth to two major innovations. The first one is something called deep optimizers. All that really means is that the learning rules themselves get smarter. They can actually learn and adapt. And the second one is continuum memory systems, which, as you can probably guess, completely rethinks how AI memory works. And this right here, this is the real heart of the solution.
A continuum memory system, or CMS for short, basically throws out that old, simple idea of short-term versus long-term memory. Instead, memory becomes a whole spectrum. Just picture a chain of different memory modules. Each one holds a different kind of knowledge and updates at a different speed. What you end up with is this rich, multi-layered memory system that, well, it starts to look a whole lot more like a real brain.
Of course, a great theory is only as good as the results it gets, right? So the researchers went ahead and built a proof of concept model to see if this whole nested learning and continuum memory thing actually works in the real world. So let's meet their creation, the HOPE architecture. So HOPE is a brand new AI architecture built from the ground up on these principles. But here's the really wild part. It's self-modifying. Because the learning rules and the structure are all one system, Hope can literally optimize its own memory as it learns. Think about that. It's an AI that actually learns how to learn better over time.
So, how did it do? Well, the results are looking very promising. What we're looking at here is its performance on standard language and reasoning tests. Now, the two key numbers to watch are perplexity. Think of that as how surprised the AI is, so lower is better, and accuracy, which is pretty self-explanatory. Higher is better. And as you can see, Hope is clearly outperforming other advanced models like Transformer++ and Titans. But check this out. Where Hope really shines is on tasks that need long-term memory. This chart shows how it did on what's called a needle in a haystack test. That's where you basically give the AI a massive wall of text and ask it to find one tiny specific detail. And look at that. Hope just blows the other models out of the water. This is the proof right here. Its continuum memory system really is better at managing information over long periods. So what does all of this mean for the future of AI? Well, by bringing a model's structure and its learning rules together into one thing, nested learning isn't just some small improvement. It's more like we've just been handed a brand new blueprint for designing AI.
You know, the researchers themselves really sum it up perfectly. They say that this nested learning idea offers a real solid foundation for finally closing that gap. The gap between the limited, forgetful AI we have now and the incredible, continually learning abilities of the human brain. And that leaves us with one last, pretty mind-blowing thought. If an AI can learn, if it can remember, and if it can even change how it learns, are we on the verge of creating a truly self-improving AI? An AI that doesn't just know a bunch of stuff, but one that actually grows, adapts, and learns from every single thing it experiences forever?